This is the review for Chapter 9. We're looking at our four types of equations, and we have to determine which one is an ellipse, which one's a hyperbola, circle, or parabola. Looking here, we have the x squared, the quantities x squared, y squared, x squared, y squared. Here you only have one of them squared. So the one that's only the type of equation that only has one squared would be a parabola. This parabola would be opening up to the right or to the left, depending on what p was. The one that has the r squared, of course, is your circle. Here you have a plus in between. You have your x squared and your y squared. There could be a possible translation. This would be an ellipse. That's a horizontal direction. The major axis is horizontal. This one here has a minus sign in between your x squareds, y squareds. So you know that that has to be a hyperbola. Since the x squared is first, you know that this also opens up with the transverse axis going horizontally. We're going to write an equation that's a perpendicular bisector of this segment. So I often like to make a sketch. -3, 4, 5, 6. So there's our AB, segment AB. We need to find the midpoint and the perpendicular slope of that. So I need to know the equation of that line. We see that it's going to have a negative slope. It's going to be a pretty large slope, and it's going to have a relatively large y-intercept. So the first thing we need to do is look for the original slope of AB. Or you could find the midpoint, one or the other. But I'll find the slope first. The slope of AB. We're going to take our y values, so 6 minus 4, 5 minus a -3, which is 2/8, which is 1/4. That's the slope of AB. So the perpendicular slope is going to be the negative reciprocal. So it's positive currently now, so it's a -4/1. So we could call that -4. Next we need to find the midpoint of AB. Well, using the midpoint, we're going to take the average of the x's. So we add the x's together, divide by 2. Add the y's together, divide by 2. So we know at 1, 5 is our midpoint. That's the bisector portion of it. We know the perpendicular slope, and we know a point that it goes through, so we can use y minus y1 equals m, x minus x1, plug in our point that we have, our slope, our x value, that's the equation of our perpendicular bisector. We're looking at this equation. we have to determine what type of graph that is. Well, I noticed that only one of the variables is squared, so that means it's a parabola. The y is squared, so I know that it's going to be opening either right or left. And because the coefficient here, which is called the 4p is positive, so it will be opening to the right. 4p, remember our equation, general form looks like that. So the y squared, the x, the 4p is the 12. So the 4p equals 12, so that means p equals 3. There's no parentheses, so there's no translation. So we're going to have a vertex at 0, 0. We're going to have a focus point 3 away from that. We're going to have a directrix the other direction, x equals -3. A line of symmetry is your y equals 0. So coming over, we have our vertex at 0, 0. We have our focus point, p is 3. So 1, 2, 3. A directrix is the opposite direction. So x equals -3. And then we're going to pick some points. We're going to pick x values, and then we'll take the square root of that. So some x values we can pick. We can pick x is 1, x is 2, x is 3. Of course, when x is 0, we get y is 0. That's the vertex. When x is 1, you end up taking the square root of 12. So when x is 1, we said y squared equals 12 times 1. Y squared equals 12. Y is going to equal the square root of 12. Which is 3.46. So we get plus or minus 3.46. The next one, we're going to plug a 2 into there. So y squared equals 12 times 2. Y squared equals 24. When we take the square root of 24, you could simplify that in radical form, but that doesn't necessarily help us with graphing. So we'll put this into a decimal. Plus or minus 4.89, or maybe even 4.90 if you round up from the next value, but that gives us an idea of where to plot it. And then our last one, when x is 3, y squared equals 12 times 3. Y squared equals 36. Y equals plus or minus the square root of 36, which comes out to a nice clean 6. So we'll plot those points now. When x is 1, we get a y value that's a positive 3.4 and a negative 3.4. When x is 2, you get positive 4.8 and a negative 4.8. And when x is 3, you're getting a positive 6 and a negative 6. So now we see how the graph would come out and start to curve. And we label our equation. Y squared equals 12x. Looking at our next equation, we see that we have both the x and the y that are squared. It looks like there's an h and a k, so we know that there's a translation. It's a plus, so it's either one of two types of graphs. It's either a circle or an ellipse. Because the coefficients are the exact same, or the denominators are the exact same, we know that this is a circle. We have a center at -2, 3, and a radius, r squared equals 25, so r equals 5. So we'll come over to do our graph. We look at -2, 3, and do a slope of 5. And we do that in every direction. And we write out the equation.